Alright, today we're going to look a little bit at how to use the fork system call. Now I've used MOBA Xterm to log into the Linux lab at the university, and let's go ahead and just get an editor up. I kind of like gedit, so we'll call it fork exec.cpp. Great. Now a lot of these system calls are in include files, so we need to go ahead and include a few of these. We'll include IOStream because we often need to print out to the screen. I'll include unistandard.h. I'll include standardlib.h. This has the exit call. And I'll include syswait.h. That has the wait call. And we'll use namespace standard so we don't have to type that in. Great. Let's get started. First thing I'm going to do is I am just going to go ahead and call fork. And so let's see what happens. Let's print out the PID, or the return from fork after it's called. Let's go ahead and save that. And we'll go over to a window on the same box. Notice there's my fork exec CPP. I'm going to go ahead and build that. And we'll put the executable in fork exec.cpp. fork exec, and off it built. Now if I want to run fork exec cpp, I need to go ahead and indicate which directory it's in. It's in the current directory. Let's go ahead and run. Look at that. What happened there was when the fork system call was made, a new child process was created, and both processes were exact replicas of each other except for the PID, or that return from fork. So here, that PID, or return from fork, actually came back as a 0 in the child process, and it was the actual process ID of the child itself in the parent process. We can now use that PID to decide which fork we want to run in. So let's go ahead, let's go back and look at the output again just so you can see. Two processes. The child printed out, the parent printed out 7998, which was the PID of the child, and 0 came out of the child process. Great. Now the common pattern is to use that PID to decide if you're in the parent or the process. And so I can say if the PID is equal to 0, then I know I'm in the child, and I can do child things. And so for the child, let's just have the child go to sleep. We'll say sleep 3. So we'll have the child sleep for 3 seconds. And then we'll have the child awake. And he will print out child awakes. Perfect. Now what should the parent do while the child is sleeping? Let's actually have the parent wait on the child. So else, this will be the parent side of the house. We can just say int, we'll call it wait PID. This is the PID that's returned from the wait. And we'll have him wait on the child. Now that takes in a pointer to a status, which is an integer. So I need to declare that as well in status. Great. And when we return from the child, we'll just have the parent print out that he's back. So parent returned from child wait. And let's have the child PID printed out as well. PID. Perfect. So what's going to happen? I am going to fork, and then I have two processes now. In one of the processes, and they're exactly the same except for in one process, this PID variable is equal to 0, which is the child. The child will sleep, and then print out that it awakes. And in the other process, which happens to be any PID that's greater than 0, we're the parent process. It's going to wait on the child, and then it's going to say, hey, I returned from the child. Let's fix this here. And let's save that. And let's run it and see what happens. So first we need to build. And then we can run. Looks like the child is waiting. The child awoke, and then the parent awoke. And notice the PID is 8312, which is the PID back. Let's go ahead and change this a little bit so we can see a little better what happens here. Before the child sleeps, let's actually print out. Let's get the PID of the child. Int, we'll call it child PID equals get PID. And we will say cout. We'll write it that the child is actually about to go to sleep. Child PID is sleeping. This will let us see a little bit better that the child is about to sleep. All right, we'll save that. Let's go ahead and build and run. There we go. Child 8576 is sleeping. There's the 3 seconds. The child awakes. The parent, which was waiting on the child, wakes and writes out the PID of the child, which is passed through the wait system call. 8576 we see there. Great. So this allows us to create two processes that do exactly the same thing. However, it's probably more interesting to have the child process do something a little different than the parent process. That's where the exec system call comes in. So now when the child awakes, let's go ahead and have that child do something a little more complex than just print out the note. Let's actually have him run a different process, or a different executable, I should say. And you can do that using the exec LP system call. And I'm going to have that process run the ls command. So the exec LP takes in a few arguments. The first is where you will find the ls command, then the ls itself, and then a string of arguments you want to pass the ls. And I'm going to just pass in the -l. The end of that string is indicated with a character pointer to 0. Great. So now the child will wake up from its 3-second sleep, and it will exec within its context the ls command. Let's go ahead and save that, and come back here and build it, and then execute. There is the child sleeping. It wakes up after 3 seconds. Within the child process itself, it executes the ls command. Then the parent wakes back up because the child is finished from the call, and it prints out its message. Let's do one other thing. Let's go to the child here. First, let me clean this up, put a little space after the wait to make it look a little cleaner. Let's print out here a message. Do I ever see this? And you can ask yourself, will you ever see that printout? I'll give you a second to think. The answer is no. Within this child process, you never return from the exec unless it fails, and then the return code will be less than 0. But if the exec is successful, it has overlaid the entire image of the process with the ls code. Let's see if I'm telling you the truth. Let's build it, and off we go. So there's a child sleeping for 3 seconds. It will wake up, run the ls command. Notice I never see that message, do I ever see that? That is because the ls has written completely over the child process. Thank you very much. I hope this made sense.